The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. The most important thing first, can you see the presentation and can you hear my voice?
Yes, Laura.
Brilliant, thank you. Warmly welcome to Visual Components 3D Factory Simulation webinar. It's very nice to see that there are so many people on the lines now all over Europe. I am Laura Mertanen, Marketing Events Manager at Visual Components, and today working as a host for this webinar. I joined Visual Components around 1.5 years ago, and I'm responsible for organizing and managing different kinds of events globally. These include trade shows, seminars, and also virtual events. I will quickly introduce first our today's agenda and then follow with the practicalities around the tool. So to make it more dynamic and engaging for you, we have structured the agenda so that the presentations will be following with live demonstrations. We will start by Mikko Urho, our sales director, introducing to visual components and simulation. Samuli Ahonen, simulation expert team leader, will then give a demonstration on the topic. After, Mikko Salminen, EMEA sales manager, will introduce an interesting thoughts about the future of the industry and also the new features of the software and briefly process modeling. Again, presentation will be following with live demonstration and setting up a simulation of a layout. Demonstration is given by our simulation expert, Reza Changizi. We have reserved time in the end of the webinar for questions and answers, but please feel free to raise them through the whole webinar. Hopefully we have time to go them through in the end of the session. And today's webinar is scheduled to end by 12:30. Here are our today's speakers. We are all in normal situations located in our headquarters, so in Espoo, Finland. I will now briefly introduce the tool we are using today and how this webinar will be run. So all the attendees are muted to avoid possible background noises. Webinar will be recorded and the recording itself, together with all the presentations, will be shared then afterwards with all of the attendees. If you have any questions, feel free to raise them through the questions box, the questioning functionality, and we will try to answer them after each presentation, but then eventually during the question and answer time that we have reserved in the end of the webinar. This GoToWebinar tool also has the raise hand functionality, but due to the big audience today, we are not using this, so feel free to raise all the questions to the questioning box. And if you have any questions, especially if you have any questions after the seminar, after the webinar, we hope that you will be in touch with us. So here is our sales email address, sales@visualcomponents.com, where we hope that you will be in contact with us and send all the possible questions that you have. But I will now gladly give our first speaker, so Mikko Urho, the presentation, right? So Mikko Urho, feel free to start your part.
Okay, thank you, Laura. Can you hear my voice and see my presentation?
Yes, very well. Thank you, Mikko.
Okay, so my name is Mikko Urho, and I'm a sales director of Visual Components. I'm running the sales team in our Finnish office, and I joined the company 2003. My presentation will be an introduction to Visual Components, so I'm going to tell a little bit more about us and about our products and solutions, what we offer to our customers. First, some words about the company. So company was founded in 1999, so we turned to 20 years old last December. And we have been working with the worldwide partner network, and our customers are typically related to manufacturing, automation, or system integration. We have 3 offices. Our headquarters is in Finland, in Espoo, close to Helsinki. There we do all the development for the product, and also we have their core functionalities for marketing and support. We do also have 2 sales offices, one in Germany, which is serving our customers in German-speaking areas in Europe, and also we have an office in Michigan in US, which is supporting our customers in Americas. Here you can see a map, and with the yellow color you can see the countries where we actually have partners. So maybe you can also find your country there, and this is just to let you know that there is a local support available. Few words about our markets. Our customers are typically they're machine builders, system integrators, or manufacturing companies. So machine builders and system integrators, when they are creating new layouts and they want to present to their customers or partners, they are typically using visual components there. And more and more also manufacturing companies, they are using simulation and visualization technologies, and we have a growing amount of customers in this sector as well. When it comes to the industry verticals, our customers can be anywhere from pharmaceuticals to electronics to food and beverage or automotive or aerospace. So we are not tied to really to one vertical. There's a video just describing a little bit the concept. So with visual components products, you can simulate production lines or factories, and we are supporting material flow and robotic simulation in the same platform. You can also simulate resources, like in this case we have a human resource doing an assembly task. So the idea is really that you can simulate all steps in your production line, and also you can analyze your production system, so you can get statistics out of it. It's very visual as well, so many of the companies are using this as a communication and sales and marketing tool. Then this next slide, we have few words about, I'm going to tell how simulation can benefit you. So the game is changing, and Industry 4.0 has been really booming many years already. So simulation and visualization technologies is also part of that concept. And when it comes to visual components, so how we are helping our customers in that field is that you want to create new layouts or do some performance calculations for your production lines, visual components is used there. But you can also step into your production line. So you can use VR technology, so virtual reality. You can create the model with simulation and step in there. And also you can connect to different kind of controllers. For example, you can do virtual commissioning by connecting to your PLC and so on. As we all know, there's challenging times at the moment. There's a lot of uncertainty at the moment, and but we see also that many companies are changing their production at the moment, or they are doing new plans for the future production. There's a lot of limitations, and how manufacturing simulation can help you there. So you can design smarter solutions, but also the communication is a big part of it. So you can easily involve people and decision makers while you are doing these nice simulations, and you can talk around them. And of course, because it's simulation, then you can get also some performance calculations, and you can validate changes virtually. And at the end, of course, it's interesting to know what is your return of investment. So if you are investing to your production it would be nice to know that, okay, with simulation you can estimate it, what is the capacity and when you will get your money back. And a few words about Visual Components products. So we have 3 levels in our product family. First one is Essentials, and that's a layout tool. You can create from existing components. You can create your layouts very easily. We will see that in the demonstration soon. And then you can also get different kind of results, like nice pictures or statistics out of it. Professional level, you can actually create new components. So it has all the capabilities from Essentials, but you can also import CAD data and create your own component to the library and use it in your layouts. Premium level is a flagship product, where we introduce also some additional controller connections in the PLCs and robotics side. But there is also interactive VR functionality. And also we have also some additional functionalities for creating robot paths and helping our customers to do kind of offline programming applications in robotics side. Next, a few words about the workflow, how it works with Visual Components products. So like already in previous slide, I mentioned that with professional and premium products, you can create new components. So you can import the CAD data, and then you can create a component to your library. And we do also offer a big library of components. I have a slide about that in, I think, next. And from these components that you have created by yourself or from Visual Components library, you can create easily your own layouts. And as a result, you can get different kind of results. You can have a 3D PDF, for example, like in this slide. So you can easily share your work with other parties. A few words about the component library. So this is something that our simulation expert team is developing all the time. So we are introducing new components time to time. Maybe you have seen those in the social media as well. It includes over 2,400 components, and from those, over 1,400 are different kind of robots or different brands in the robots field. And there we have also some example layouts. In general, components we have conveyors, machines, resources, robots, workpiece positioners, basically all kind of things that you can actually, or what you need in your production line. So the idea here is to make your work easier when you are creating layouts, so you can find these ready-made components from Visual Components library. And this is all in cloud. So basically, if you are developing something today, to new component to the library today, and we publish it in the library, you can have access to it immediately from your own Visual Component software. Some words about the results. I think we will see these in the demonstrations from Samuli as well, more in detail. So, but you can create nice visualization and 3D simulations. You can also have 2D drawings, or so you can create 2D drawings from your 3D model. Nice images or videos, 3D PDF, like mentioned already, or if you want to have this VR model, or if you want to have the model in your mobile, that's also possible. And also, as mentioned already, the statistics and reports. This is my final slide, just to show you what you can create with our Blender add-on, what we have in the product. So you can really create nice looking videos from your simulation and use that also in your presentations and in the marketing, which looks quite realistic already. So this was a short presentation about Visual Components. products and customers and about us. And if there is now any questions, I would be happy to answer to those now.
Thank you, Mikko. We actually have one question here waiting. So what kind of extension we need at 3D model, so CAD, to add in library? So STP, STL, or another?
Yeah, we support STEP and STL, but basically we support all the major CAD formats that are available. So I believe that could be also something we show in the demonstration in more in detail. But yeah, basically any CAD files we can import, or the major ones.
Thank you, Mikko. That was the question that was waiting for now. So I think
Okay.
we'll take the next speaker then.
Yeah, that will be Samuli Ahonen. Samuli, please.
Yes, hello, and thank you, Mikko and Laura. So my name is Samuli Ahonen. I'm the simulation expert, and I started using VC a long time ago. I was a happy customer first, using it on the customer side, and joined the team later to Visual Components. And my part today will be a live demonstration of the product, kind of like a quick overview. So if you, Laura, could make me a presenter, and I'll share my screen. So I won't go too much into the details how we built these models. I will explain the concepts, but towards the end of the webinar, there will be a bit more extensive demo on how we actually create layout fairly similar to this. So what you see on my screen currently is a typical simulation layout, fairly simple one, but it has some nice aspects, different things that you can simulate in Visual Components platform. So we're simulating here human operators, some manual stations here, some defect work is happening on this separate station. Then operators put the material into a more automatic side of the production system, where we have first some sort of a buffering station, and then we have a CNC station, which is tended by the robot on a track. And then finally, the products will go to this palletizing area, where they be palletized on a Euro pallet, which will be then routed away into some sort of a labeling station, and off they go. Of course, in the real world, something would continue happening here, but in this case, the simulation, the story ends here. And we can run this simulation and see everything works. Robots are reaching their targets, they're not colliding, things like that. But of course, on top of that, it's not just a nice looking animation, it's an actual real simulation. And we can study the numbers, what is happening actually in this layout. So we can see, for example, now in the statistics dashboard that I opened, that my operators are heavily utilized, probably being now the bottleneck for the whole system. So they are all peaking close to 100. And we can see how much scrap station utilization we've had. Then we can see, for example, how much we get products out from the system. Here we have the cumulative total. Then we have the number of defects. And then in the lower section, we have the system output per interval. I'm using now 1 minute interval in this simulation for this data. Then we can study things like the buffer station capacity, the milling station utilizations, and things like that, which will help you to balance your system and study where you might find some ways to improve the production. And it's easy to create different kind of what if scenarios, having, for example, different number of CNC machines or having different number of operators in your simulation. So let's say that we've kind of designed this kind of a new system. Maybe this is the first concept that we are trying to put together, or maybe the third concept that we are planning to install in some new factory or an existing factory. And of course, in projects like this, there's always a lot of stakeholders. So we need to be able to share what we have created, like MIKKO mentions that there are different shareable formats. So one nice feature is, for example, this recording to visual components animation. So I can start recording my simulation into an animation file that we can run in freely available visual components experience product. This visual components experience product you can run also on mobile phones or tablets, Android or iOS. So you can easily have these different kind of conceptual animations in your pocket when you are visiting in the future, maybe a trade fair show or seeing customers. And here I'm running this now on my desktop application, but you can also experience this in virtual reality and go and jump into that layout in real scale. But it's a nice tool to share your animations. Another option is that you can create a PDF presentation of your system. In a similar fashion, you would record it, but I have already pre-recorded the PDF file. The nice thing about the PDF is that almost everybody has the Adobe Reader already installed. So you can just email the file and they can double click it and they would see this. And they could also see this PDF in your own PDF template. So this is created on top of Visual Components default template, but this could have your own corporate identity, and you could add bill of materials to certain highlights of your layout so that it helps, for example, whoever receives this file to click on it, they can see that, oh, there's that parametric vertical mill, and you could add extra information about each of your highlights there. So it's a great communication tool. And as I mentioned, for example, if this would be designed to be placed in an existing facility, maybe you would like to double check that it fits into that facility. One easy way to double check it is that if you have a 2D drawing available in those standard formats, DWG or maybe DXF or something like that, you could check that maybe this is the space that is reserved for this particular station or line, piece of production line. And you can see that it fits there. And you can measure this 3D against 2D and see how much space and how you would do your real estating. You can also go the other way around so that you can go on the drawing tab and load in A3 size paper, and I will add the top view from my existing 3D layout. So it generates a 2D drawing basically from any imported 3D data. So it doesn't need to be in a specific format. I'll change the scale a little bit so that it fits on the paper. In a similar fashion here, we can create the bill of material. We can add more balloons like that. We could also double check again that how much space we would need for this system, something like that. And then later on, this drawing can be also exported out in standard 2D formats like DWG and DXF, or maybe a PDF. So yeah, that's how you can communicate with different stakeholders with the help of visual components and really improve the communication and the understanding around the project like this. And now a couple words about how these are made. So the idea in visual components is that we have this e-catalog, electronic catalog or equipment catalog, where we can find different models. So we would have here, for example, robots and different equipment from ABB, or we would have CNC machines from Feeler, FFG Feeler, or we could find different kind of KUKA equipment. And you can see that there's lots of different manufacturers on that list. Maybe you would like to have some grippers from OnRobot or so on. And one of the manufacturers in the list is Visual Components. This is a list of generic multi-purpose components, if you will. So for example, if we take a conveyor, it's not from any particular conveyor vendor, but it's a generic model that you can use in your layouts. They are very parametric, so I could say that I need 2 meters of a conveyor belt, maybe 300 millimeter width. Maybe I need a roll conveyor, or maybe I need a multi-belt conveyor like such. Or if you connect these into existing line, they also can automatically copy the properties of previous, so it makes it easy to build the line. And in this case, maybe we would like to split the outcoming pallet flow into 2 separate lines. So I'll take this shuttle that will move left and right, and I will need 1 input, and I will need 2 outputs that I separate by 5 meters. And I will plug this in. Actually, I will make it a little bit longer that the pallet will fit there. So something like that. Then I can simply copy and paste existing components and snap those together. And I will speed up my start of the simulation so that we get quickly some products out. So there you see that we are now with the shuttle separating the flow to left and right. I hope it goes smoothly, the animation also over the GoToWebinar, that you can see what's happening. But okay, of course, we don't have all the equipment in the e-catalog. You will need to, in certain cases, create your components on your own. Let's say that there's a custom-made device, some tailored device in the production, and obviously we don't have that device in the library. Maybe you find something similar in the library, you can take that and modify it, or you can even start from the very scratch and create your own models. And that's why we have this modeling tab. There was already a question that what kind of CAD formats do we support, and before going to that, we also have a very simplistic 3D modeling capability inside Visual Components, but we are not the best 3D modeling. We are not trying to compete with CAD tools. So in often times, people already have their CAD data and they can import that. So we can go and find, for example, a SolidWorks part. So let's say someone saw this layout that we created, but they said that, hey, the outgoing product package or the pallet needs to be weighed. So we need to put it on a scale so that we know how much mass there is going out. And someone provides us the scale SolidWorks model. There's tons of different formats that we can support, like CATIA and ProE and Creo and you name it. So I'll import this SolidWorks file. I can define how detailed version of that model I want to import. I go somewhere in the medium, and I'll go ahead and just import it. And there we have our very simplistic 3D model. But we can't use this together with other models because the system doesn't know what it is. It just knows that that's the shape of it. So on the modeling tab, we need to basically define how this component acts. What is what is the behavior, simulation behavior, and that we can define with the help of what we call behavior objects. We also have wizard, and you can also make it parametric, so you can add different properties. For example, make the length parametric. So in this case, I will first introduce that it's kind of like a conveyor type of a component, and that wizard now created these connection points for us, and I could double check if they went to the correct locations. And I'm happy with what the wizard did automatically. Now we can go and actually we could go now and save this model into our custom libraries, so that when we would do a next project, we would already have this model available in our e-catalog, and we could use it in a similar fashion. We can use these online components. But I will go now and put this together with my layout. So I'll put it right there, and I connect that back there, and I'll use the help of ready-made components here called conveyor utilities, things that we can snap on top of a conveyor. And I'll take a simple process point. I'll snap this on top of it, and I will define that it takes 40 seconds to weigh the outgoing product. Now when the product comes, it stops on that scale for 40 seconds. Of course, now it goes very quickly because my simulation speed is fastened quite significantly. So yeah, that's kind of like the main idea, how you build layouts from the components. A couple words quickly about robotics. We don't go too much in details when it comes to robotics and robot teaching and programming in this webinar. If you are interested in that more compared to what you will learn today, don't hesitate to contact our sales at visualcomponents.com so we can educate you more on the topic. But now in this, we have this robot doing the palletizing, and it's this visual components robot doing this palletizing, and this is something you can't buy in real world. It's an imaginary robot model. So we need to double check that what robot could actually do it. So I will take, for example, KR16, and I take actually the long version of that KR16, so it has a little bit better reach. And the easiest way sometimes to kind of imagine the reachability is to check the profile of the envelope of the reach. But of course, you can also switch different robots with each other and test if the robot will do the job. I will move that robot a little bit away, and we could now simply double check, for example, that would it reach here? Probably will nicely reach and pick that product from there, and probably will nicely reach in this area also to do the palletizing. But the best way to test it is to simulate it. So we need to wait a little while so that we get the products. So let's speed it up a little bit. And here we start to get the products, and we can see that the KUKA robot is also capable of doing that. And of course, we could also here manually teach robot movements, but Reza will show a little bit more automatic way of teaching the robot. This robot program can even be exported out to real robot program if you want to then program your robots in simulation world and then use that program on real shop floor. So that is also possible. But that's in a nutshell what Visual Components is kind of all about. I didn't show everything that it can do, but I tried to give a quick overview on the different aspects that you can do with the tool. So it really starts, for example, from conceptual layouting, that you just put things on the floor and try to kind of brainstorm an idea how the layout could be. Maybe you don't even hit that play button when you create your first models, you just put things together. And then, of course, you can go and simulate it and have a bit more detailed analysis, maybe with the help of the statistics tool that I demonstrated. And you can program robots in the same platform and even kind of generate the real robot program code. You can do virtual reality representations. Maybe you want to double check some ergonomics in virtual reality. And down the line, which we don't too much demonstrate in this particular webinar, is the connectivity feature. And with the connectivity, you can connect your simulation models with the real controllers. So you can, for example, validate your PLC code, or you can use the simulation to develop your PLC code if the real hardware doesn't yet exist on the shop floor for controls guys to start developing. And it could be used for remote monitoring and different other use cases. So that's it from my side. If you have time and if you have questions, happy to answer. Also at the end of the webinar, we should have some time for questions and answers.
Thank you, Samuli, for excellent demonstration. We actually have a lot of questions here, but unfortunately, since we try to follow the time given, so I will only read few of them or pick one from here. So this question came in the beginning of your demonstration. So how long does it take to simulate something like this?
Maybe it's the question, how long does it take to build the layout, but something like this. And it would probably take, depending on the details, the devil is always in the details, probably a half an hour to some several hours, depending how detailed certain definitions is there. But Reza will show at the end quite similar, not maybe as complex as this, but very similar. And he can put that together in just a matter of like 15-20 minutes. But yeah, then how long it takes to simulate it, that also depends a lot on how much detail. So now here we have detailed, for example, that human operators and robots and those are, and the CNC machines are simulated quite in details. So you can simulate maybe a couple shifts in couple minutes. So that would be kind of like how fast you can simulate it. But that really depends on your model.
Thank you, Samuli. I think we will now move on to and give the speakers rights to our next speaker. So MIKKO Salminen, please go ahead.
Thank you, Laura. Can you see the screen and hear me?
Yes, thank you.
Okay, so good day, everyone. My name is MIKKO Salminen. I'm working for the sales in Europe, and I've been with Visual Components since 2008, but I know the company since 2001 as a user. Stepping into the actual topic and stepping into the virtual factory. So what Samuli created there now is a simulation of a certain factory, certain scenario. You can also step into this, so you can export in the same way as you can export a 2D drawing or animated 3D PDF or video. You can export an animation file, and this animation file you can open up in the free viewer Visual Components Experience. This is available both as a desktop version for your PC, in which you can also run it not only for the 3D animation but for actual virtual reality and step into the virtual factory. Or you can use the same VCAX animation file on your mobile device, so Android and Apple, and the same file will run there. So you can take several factories in your pocket, for example, when visiting some trade show in the future and showing your prospect customers what you could do for them. And it's rather effortless to create these, so it takes a couple of clicks and some seconds or minutes of waiting. But what we're more discussing now is how to use these virtual factories to plan for the future. So at the moment, nobody really knows what's around the next corner, and that's where simulation comes in handy. So we're trying to help you guys with the issues you're facing in, for example, factory design. You're struggling with many different layout alternatives. There was a question about, can you compare a before and after scenario? And yes, you can. You can also compare different alternatives, iterate with different input parameters and resources, etc., etc. How you do this typically in the past or have done is with tools that are for experts. And this is what we are changing, that the basic software is very easy to grab and use, and anybody can simulate some basic scenarios. And the results are always visual, in 3D, they are easy to export and present. And in the past, it used to be completely the opposite. So you had to really decipher these models to understand what's happening. And it used to be very hard to convince the decision makers with the traditional ways of maybe making blueprints or just crunching some numbers. But when you do it in a visual way, you can really involve the people much easier, like Urho said earlier there, and just show them how this system would work. And if we change this and this, what's the effect? So we come from that layout planning to the actual production planning, and especially in these times, the demands and needs are all the time changing. It might be that some factory closes in one country and you need to move your production to another country. How to ramp up the production there, that's a tough job. You might not have all the resources available. Might be you need to keep social distancing, or it might be that some people are sick. It can be different reasons. And how to cope with those what if scenarios when this and that happens, then either when it's already on or when you are kind of afraid that something like this could happen, then this is one of the things that simulation is good for. You can play around with the scenarios. So there is a constant pressure on your manufacturing system and the supply chain, and that's where simulation comes in handy. It's a tool to kind of predict the future a bit better and be more prepared for what might come. Here's a little example Samuel prepared, and it's this kind of job shop. It's a typical day. Everybody's working there happily. There's eight people doing some manual preparation work, carrying the stuff to warehouse, from warehouse to the machining areas, and just filling and emptying the buffers for the robot, which is again tending the machines. And we're getting about 135 parts per hour from this system. Then there might be disruptions, especially we see in these coronavirus times that there are certain weaknesses related to the modern way of manufacturing, searching for the cheapest way to produce, or linking together different processes in different locations, different countries, etc. So the supply chains don't have this kind of robustness anymore in them. And the production has been designed to run under normal environment, and no one wants to bring kind of the bad news and say that, okay, what if that happens, so what do we do? So we are not prepared. So for example, if we take into account, there was also a question about social distancing and how does that affect our production? Let's have a quick look. What if we only have 2 operators? What do we have to do? So we maybe have to prepare automated handling of the workpieces between the warehouse and the machining area and this preparation area. And as you can see, the output of the line, even if we do a bit of automation, it's dramatically dropping because our bottleneck is the manual preparation work. So instead of 135, we're getting about 54 parts per hour. But this is maybe the situation where we're forced to be, and that's it. So in these what if scenarios, you can start to play, maybe preparing again for the future, thinking how to improve this current scenario. So you can plan the production, plan the supply chain activities, in this demo case, we're not really going for any input of material or arriving materials and part of that supply chain processes, but more the actual on-site production. You can evaluate different kind of production strategies against different scenarios. You can play with the amount of resources and so on, and try to build some flexibility and robustness into the system, and understand the different kind of issues, risks, and costs involved in the decisions or the investments you might take. So a kind of simple question from that previous layout is, how can we then maximize the output if for some time we only can have those 2 workers in this area due to safety issues? So let's see, one of the ideas that could be that, yeah, in the preparation work, there are a couple of steps that the Cobot could do. So instead of just running it fully manual, we have assisted manual work in a co-working cell with the Cobot. And it could be holding some parts, picking some parts, even doing some basic assemblies or deburring activities or different kind of things. And in this scenario, we have done a couple of steps where we then increase the output from 54 to 75 parts per hour without any other changes. And this is actually a change you could make happen in a short period of time, so something you could implement on the shop floor rather quickly. If you then think about how to brainstorm about the different situations and how to prepare for the future, then it's not as easy anymore. We've heard stories from customers that they cannot go anymore, for example, to China to discuss about future products and their prototype assemblies and how to put them together in the shop floor. So you are not able to visit the real shop floor and not able to have the actual physical prototype in front of you. So the virtual factory will be your next best thing to go forward with the planning. And you can show the new ideas, their effect in practice, and it makes it easier to understand that, okay, this is what I proposed, so what's the effect of this in practice? So if we would, for example, now look for better times and getting back on track, what's the effect of having more operators? This could mean 4, 6, 8, or anything. But in this scenario, we have now prepared one where we just add again number of operators. We don't have the Cobots actually anymore. It's just operators, 6 of them. And we already see that now from 74, we are coming now to 163. And if you compare to the 2 operators, that was 54 or something there. And so we are more or less tripling our output. So we can see that the bottleneck is still the preparation area. And actually, if you would now upgrade this to 8 operators, it would only go up by 26 parts. So you start to see that, okay, with that number of operators, the automated handling becomes the bottleneck. And so your bottleneck is shifting from one place to another based on the changes you're making. Okay, that's just to give you some ideas of what kind of things you can do with simulation. And Reza will come back to how to define these processes in a bit more detail, and we have a couple of slides about that later, but let's look into some new features in the premium product. And in the 4.2 version that has been out for some months now, we are running in the premium version the interactive virtual reality. So from all levels you can produce the animations, but the interactive VR is something that is available only in the premium product. Basically, it means that you can stream your simulation into VC experience, into the virtual reality. And there are these kind of virtual reality events that you can use in your models. And there are some sample components that are prepared for interactive VR available in the online library. In this case, the operator is just jogging the robot, opening the doors, as well as then starting up certain actions or processes like closing the doors from the HMI, starting the actual process, and so on. So again, this layout is now running in the simulation, but it's just visualized in the VR, but the user can in the VR interact, and these interactions are then kind of reflected to the simulation world. So you could even hook it up with the PLC controller on the simulation side and do virtual commissioning. One of the new things coming up in the next version, 4.2.2, in the premium product also is a direct interface for Siemens PLC connectivity. And basically, it's been possible already to go through OPC UA to the PLCs from Siemens that support OPC UA communication. But in this case, you can directly interface, and it allows a larger number of inputs and outputs, as well as a better refresh rate or polling cycle. So helping you to do slightly larger layouts when it comes to virtual commissioning. But that's it before going to the process modeling. Is there, Laura, any quick questions at this point? I know there was a ton of questions and very good questions. We have to come back later, but anything quick we could grab now?
Thank you, Mikko. Yes, there are a lot of questions again, but I will now raise one of those here. So is it possible to run two different versions of simulation, like before and after situation, and compare these two for a special monitor some basic KPI metric changes?
Yes, so you can make it quite common also that you could, for example, make a current state and the kind of future state or ideal state where you would like to be, and compare the required investments or changes in your production that you need to take, and then see those effects and calculate your payback for the investment. So you can collect statistics from all the components, all the properties in the simulation, and you can then create different kind of reports and graphs, as well as use this information for payback and return on investment calculations.
Thank you, Mikko. I think we need to move on, but excellent answer, and let's hope that we have a chance to go through as many questions later on as possible.
Okay, yeah, so let's move on to process modeling. As said, Reza will demonstrate this live, but this is the new way, the uniform way of defining your processes in visual components, and it was introduced with 4.2, and it is a collection of different things that are supported then on the software in a native level, and it means that your tasks can be completed there in the visual workflow, so you don't need to do programming with Python anymore for this and that, but more and more of the tasks carried out in production can be handled through this standard library. And you can manage your products, processes, and production flow in a very visual way, and view it in 3D. So it's much easier to analyze and kind of explain the process flow to other people when you see it on the screen, like there on the right. And what this process modeling consists of, it is a new way to define the processes. And first you define the products, and then the processes these products can go to, and then you define the actual product flow or material flow for each product flow group. So product group 2 has this geometry and this kind of properties, and then you have the process points, but actually that one goes from that process with the human operator to that one, then again with the robot to that one, with the conveyor there, and then again robot is serving those machines, and then out with the conveyor. But yeah, this is much more visual and understandable when Reza goes through it. So I'll hand it over to Reza.
Thank you, Mikko. Yes, I hope everyone is doing well and healthy. First of all, do you see my screen? You should see visual experience, yes. Visual Components Experience version running. Okay, good. So somebody already gave you an introduction, and what I'm gonna do is to also build such a layout that you can see in the screen now. So this is supposed to be a production for such pistons, and the idea is that we will bring these pistons that are already produced for the final machining process, and then from there the robot will put them in this buffer. After that, our operators will take the pistons to some inspection, manual inspection site, and from there they will deliver them to this final buffer. That's where the final product will go. So if we move to Visual Components, this is Visual Components Premium that I am running, version 4.2 at the moment. And what I'm gonna do is to bring in a conveyor, and we're gonna start from the scratch. And what's the purpose here is to produce some part using the feeders. Feeders are the points that you can basically use to bring in parts inside the simulation. That's like input of your product, input point. And here I'm producing some cylinders, as you can see. In case that I go to the products that are defined here, you can see that I have one type of product called VC cylinder. What I need to do is to bring in that piston that I already showed you, and the model of the piston is a AutoCAD 3D file. So that's the file that I just imported. So basically importing was just grabbing the part and dragging the part to the 3D world. That's one way to do it. There are multiple ways to do import your files. And yeah, so what I'm gonna do is to have inside this flow group, there could be many flow groups with many products under each. Inside this flow group, I will create a piston product and then use this 3D world selector to select this piston. So when I go back and choose from my cylinders the piston, you can see that pistons are being produced. All right, what I can do is also to create a batch of files. If I a little bit enlarge this component properties screen, we can also produce like cylinders and then also pistons. Let's produce 2 cylinders that are produced every 3 seconds, and then 2 seconds later produce, for example, 3 pistons that are produced every, I don't know, let's say 2 seconds. What I want to do is also to create my cylinders to be with, for example, yellow material. And I want the cylinder also, the dimensions, the height to be 150, and then the radius of my cylinder to be 100 millimeter. So when I press play, you can see that the yellow cylinders are being produced, and then 2 and then 3 pistons. So I just try to show you that you can also like define material and then also change dimensions, etc., etc. What I'm gonna do is to just produce piston at this point. So the interval time is 5 seconds. So every 5 seconds, I want 1 piston to be produced. Let's make another conveyor, and this conveyor will be the spot that the piston will be picked. And the capacity of this conveyor, I will put it to 1, so there will be just 1 part at a time here. Next step is to pick this piston from this conveyor with a robot to a machine. And there are different range of machines available. So I'll take this vertical milling machine, and if I just go a little bit backward, you can see that under dimensions, we have 3 sizes of the machine: small, medium, and large, and also custom size. So you can also make it custom. I'll just choose for this point the small size of the machine. And the next point is that I'm gonna define the place that the part should be picked. So it's here. I would also put it like somewhere in the middle of the conveyor. And then what I need is a robot controller. So there are a set of controllers, as you can see under this process transport controllers, this folder. And these transport controllers are for different resources, for example, like human, mobile robots, robot manipulators, and stacker cranes and vehicles. And these guys, what they will do for us, they are some kind of smart controllers that they will do the simulation part for us. They will start to move the resources automatically, so you don't need to do robot programming. It will just know automatically from where to where you can go. And I'll put a robot tool as well. At this point, I'll go to the process tab and click on the flow, and then choose the point that I want the part to be picked, and then also choose the machine that is the destination. And as you can see, there is this yellow link in between of my starting point and the destination, and I'm gonna put the robot as the resource to do it. Now you can see that the icon in the middle is the robot. So when the part arrives there, robot goes, picks it, and puts it inside the machine, the piston. Let's check what is inside the machine happening. So as you can see here, this is the process that is happening inside the machine. The machine at first is idling, then transporting in the part. Then the state of the machine goes to busy. These states can be used for statistics, so you can also define those by yourself. And then there's a delay. After 1 second, the machine door closes, and there is a process time. The machine door opens, and the state of the machine goes to blocked, and parts will be sent out. What I would like to do is to define the process time based on my product. So I don't want to have a fixed process time, but I want to have a process time for the product defined already. What I'm gonna do is to go back already to this piston that was created. And what I'm gonna do is to create a property here inside the piston that is called, for example, my time. And it's a time, the quantity. It's in seconds, and I would put here 20 seconds. So what I'm gonna do here now is to delete this process, and I would after this add a delay. So these are the list of stuff you can do inside your processes. You can create parts, you can attach parts, you can remove it, you can make buffer. There are a wide range of things that you're able to do. What I'm gonna do is to add a delay. But if you remember, I created one property called my time. So for the product that is coming in, the my time property will be used for the process time. So when the part comes in inside the machine, you can see this green bullet point that shows we are 20 seconds inside this process that is being read from the component. And this is not just the robot movements are not just simulation and or some kind of like animation, but what you can do is, for example, if you want to take this picking task of the robot to an actual robot controller, what I can do is to change here to record this action, and I will put the record name, for example, webinar program. And the only thing is, let me close this screen for machine process, and now only thing we should do is to quickly run it through. Then I'm gonna click on the robot and then go to program tab, and you can see that under the robot there is a program called webinar program. We recorded this, so this is the action that just happened, and these are robot points. These are linear point to point, and you can modify these points, you can add to them, and after you are happy with it, we have the post processor. So by choosing the robot and activating the post processor, for example, there are few controllers already here. There is KUKA and some other. So I would choose at this point the KUKA one, and we can select the output place, for example, on my desktop, and then I'd press post-process. So if I go to my desktop, you can see that the points that were created by the robot are now saved in the KUKA language. Then now we can take this to our KUKA controller and start to use them inside our actual robot controller. Perfect. Let's go back to where we were. And I'm gonna change this back to automatic, but if you wanted to modify those robot tasks and start to use them, you can use execute routine. So you will execute that modified program, but at the moment I would just go with automatic mode. Then if you saw the part stays there, and we need to define where the part should go after the machine. So what I'm gonna do is to copy the machine to some more machines, and let's create 4 machines in the -x direction. So this is like a preview where the machines will be created, and now we have 4 of the machines. What I'm gonna do next is to go and bring in a robot positioner. I'm gonna put robot positioner in front of the machines in a way that robot can pick the part from the conveyor and then put them inside each machine. Let's put the robot on the machine base. And then this smart controller, of course, is necessary. So I'm gonna attach it down there. What I'm gonna do is also to increase the length of this robot positioner. Of course, from there, robot could not reach the picking point. The next point that robot will go after the piston is done with the machining process is a buffer point. So this buffer point will be this shelf that I just imported. I want only 1 row and no top shelf. So only thing I'm gonna do is to just rotate it 180 and put it on the proper location. You can of course set these locations more accurately if interested. There is the coordinate system over here, and you can set them in a way that you desire. There is, as somebody also showed you, you can import the 2D files as well and organize your layout based on that. So if I just quickly go to process labels, you can see already the point that we want to pick the part, 4 processes that are the machines, and then the shelf buffer. So what I'm gonna do is just to delete the ones that are already there. Click on the from conveyor, choose the machines, and then I forgot to choose the robot as implementer, but now when you click on the robot controller and choose the shelf, you can also see that robot will be doing the task from the icon. And let me also change the implementer here. So the part starts to come in. If I increase the simulation speed, robot will do things faster. Let me take these links away so we see the simulation better. And as you can see, robot is populating the machines and then taking the machined products into the buffer. If we go a little bit faster, you see after a while, robot stops moving because the buffer is full. So this is the point that parts are ready. So some human operators would take them from here to some manual stations. So in the next step, I would bring in the manual stations. And they are like for inspecting the machine part. So it's already here. I was searching for the folder. It was just in front of me. Let's take 180 turn for this. So this is like a manual spot that part will be inspected. The next point is to bring in Mrs. Anna. Mrs. Anna will be doing this inspection for us. And after doing that part, she will take the part from the manual station to another shelf buffer that is our final shelf. And if you remember, I told you that we need the controllers for resources, so I need to also bring in one human controller. I'll put this controller here. So this smart component will also do the human moves automatically for us, so we don't have to create them one by one. After the parts come here, I would just send them to outside the factory. That this could be the syncing point. So this will be the point that the part will go at the end after the final buffer. And the next thing that I would need, I would like to also put under the resources, I would like to put areas that Mrs. Anna would be working, because I don't want her to be just in every place, but I want her to be in this specific task area. So what I'm gonna do is to define where is this area. So it's somewhere from this buffer to this manual station. And then what I would want her to do is to kindly take this parse from the first buffer to the manual station, and then from the manual station to the final buffer through these two areas that I have defined. So the only one thing I need to do is to connect these path areas and my resource to this controller. Now, if we go back to the processes, you can see that we have this shelf buffer, and as the final point at the moment. Then when I'm gonna connect it to manual process, you see two arrows from both buffers are coming. So what I'm gonna do is to just change this process name to shelf buffer final. So now I want to go from shelf buffer to manual process. And then again, I didn't choose the human controller, but let me activate it already. So then from this point, I want to go to this shelf buffer, and then I would deactivate the human implementer and then just send the parts from there to this sync process. So let's try to see what did I just do. Robot takes parse to the machines, and Mrs. Anna takes the ready pistons to the manual station, and then from there the parts go to the final buffer. One thing that I forgot, and it's very important, is that at the moment she does not have safety standards fulfilled. So let's put the helmet and also the glasses, safety glasses. It's very important. I always try to remember to do that. So, but now you can see that Mrs. Anna is the only operator. Maybe we would like to have few more operators. So what I'm gonna do is to bring maybe a couple of more operators. The only thing I need to do is to connect them to this controller. So all our crew will be active. So as you can see, the rest of them also started to work. And I would add also a couple of more workstations. And these workstations, as you can see, they are not connected into our work. So what I'm gonna do is to bring them also inside this process. These are now 3 of them are added. So I would just remove this point from here, and also these ones. So from the shelf buffer, I want to go to 3 manual stations, and this should be implemented by human. And then from there to the final shelf buffer, and then to the sink. So what is the result? Now all human operators should take parse to the 3 stations, and then from there to the shelf buffer. The buffer is being quickly emptied. So what I'm gonna do here, let's make a quick change to this process inside the sink. So this is what's happening inside the sinks. The sink, that is the final process. The part is transported in and then removed. That's like basically endpoint of our final machining and inspection part. What I'm gonna do is to add a condition that when the shelf buffer 2, that is this final shelf, it has the current parts more than 6, for example, start to import or start to bring in the parts into the sink. And what I can also do is to go to the statistics folder and bring in, for example, a statistics display. And then let's attach this display to the sink and press play. When I speed up the simulation, you can see that our production line has 28 parts to 30, and the value is increasing per hour, the production rate, and the parts produced are 12 parts or 16, 17, 18, and so on. So let's say that you want to check, for example, after 1 working day, how many parts are produced. So if I put the simulation runtime for 8 hours, it will run only for 8 hours, and then it will stop, and we can put the simulation time on fast mode. And if I press the play button, you see that 8 hours later, we have the production rate of 72 parts per hour and 583 parts produced. This is 1 day of working in this production line, but the simulation result was given to us in a matter of few seconds. So if you are happy with the result, perfect. If you're not happy, you can start to move around this layout parts and get different results. The last but not least, as I always say, safety. So what I'm gonna put here as the last part is to have some safety fences around the factory, or at least around the machines. So I'll put the fences until this point near the buffer, and then populate the fences around in this area. If I just a little bit relocate them, okay, that looks good. So this is our current, well, that doesn't have really any effect on the production rate, but this was what I wanted to show. At last, you can also produce high quality results out of this, like animations or 4K videos, or use our Blender add-on to share the result of this simulation with your colleagues or your potential customers. That's what I wanted to show you for today. If you have some questions, please bring them on, or then after that I will give the floor to Laura.
Thank you, Reza. Again, there are a lot of good questions waiting for you, but let's take one or two ones now. So Reza, we very much like the Mrs. Anna that you presented. Can Anna's walk path be described exactly?
Yes, the pathway can also be more. If I just go back to the simulation, the pathway can be defined exactly. It could be like narrower pathways to just ask her to go through a very defined areas. So she does not need to be like in wide areas, but it could be also more detailed and more specific.
Thank you.
Sorry, yeah, no problem. I also forgot to mention that there is what we can do is also to bring multiple controllers, and multiple controllers can be having multiple pathways and also different operators. And operators, as you can see, the color of the controller is the same with the operator, and the reason is that you can have many of these controllers and with many operators with different color of the shirt and hats. And then you can do the task allocation to different groups of operators to have different areas for them working, and based on the daily time that you want them to work, or however you're imagining the production to be. Yes, that's that.
Thank you. I think we could take one more question now for you, Reza, before turning into the question and answers part, so ending the webinar eventually. The features that we saw during your demonstration here, Reza, can all the features shown in the process demo be used in professional level of software?
Yes, they can be used. Whatever I showed is actually in the essential versions, but in case you have some own specific model that you want to bring in, for example, a specific gripper that is not in the library, or some specific machine, or some product, you can model those under the modeling tab in the professional version. But these, what I showed so far, are in the essentials version.
Thank you, Reza. I think now it's time to move on to the question and answer part. So Mikko, Salminen, would we like to prioritize some of the questions now? We have a lot of questions, a lot of really good questions. Unfortunately, I don't think we have time to answer all of them, but we will put them together and then give you an answer afterwards. So do kind of like a summary of all of them that were raised during this webinar.
Yeah, there's a lot of good questions. Thank you for everyone for presenting them. Unfortunately, we're running short on time, but we will come back to those. Maybe we can grab, I've been trying to answer several of them on the background and also sharing them with everyone in most cases. But we could maybe grab a couple of the ones that have not yet been answered. And there is, for example, about the possibility to simulate flexible product flows on conveyors, meaning plastic bottles for soaps or something like this that would accumulate. And if you accumulate them for too long distance or time, you could create too much back pressure to damage the products. So we're not doing this kind of simulation. We can do physics-based simulation, but only with rigid bodies. And you could, of course, create some sort of formula on the Python with component modeling to, if you know from practice how much back pressure, Q pressure you can have without damaging the products, and then you could have a warning if the queue is too long. Same kind of thing with the inclined conveyor. So with the system help preventing the drop of a product or a case if the slope is too much. And you can do physics-based simulation for this kind of case. Then you need to trial to see the accurate friction coefficient factors, or you could have, of course, warnings in certain components if you are planning to design incline-decline conveyors that are too high. Same actually could go to AGVs, like if you're going downhill with the AGV with a big load, you should drive a bit slower with the AGV. So this kind of things. What robot producers program export do you provide? We have multiple sample post processors, and these include the major brands like KUKA, FANUC, Yaskawa, ABB. I think there's a couple others, maybe Epson and so on. And then we have a couple of these direct connectivity interfaces to virtual robot controllers in the premium product, and this includes Universal Robots and Stoibli CS8 controllers. Then what version do you need to have from Visual Components to be able to program the robot offline and then to download the robot to real robot? Basically, you can do the simple robot teaching in every version of the software, as well as have these sample post processors. So that is available already from Essentials. Then there is nothing added in the professional version related to robotics. It's only the component modeling, but on premium, you get the advanced robotics package with the path planning, curve teaching, and virtual topology, as well as the paint visualization. And this would be the kind of offline programming version with more content and features. Then again, if you look an off-the-shelf solution for offline programming, we have partner solutions such as Delphi and Octopus, who are building their offer on top of Visual Components. So they offer then more complete solutions for applications like arc welding or milling with tailored post processors for different robot brands, controller versions, and variants. Then I need to, where is it? Yeah, is it possible to integrate the OEE in the simulation? This is also possible in the same way as we're collecting and showing other data. You can calculate OEE values based on the simulation. So having different properties exported after or during the simulation, and using these to calculate the OEEs. Again, you could also create some sort of warnings or displays either live or afterwards in a report or a graph. Then there's a question about, according to what we've seen so far, the software is quite complex, and the assumption is that there's a big amount of resources needed in the PC to run simulations smoothly. So the minimum requirements and recommended requirements, they are available on our website, and we can include the link later in the answer where to find it. But the software actually will run on a very basic laptop, and it's designed on the basic level to be a salesman's tool to show layouts to the customers and decide them on the spot. And I, for example, when I'm running the software, I have a 12-inch business laptop with integrated graphics adapter, so I have no dedicated 3D graphics, but basic Intel chip. So it runs on almost every more or less modern PC or several years back. But if you want to run big layouts or especially heavy geometries, of course, it's nice to have a good graphics card and a better computer. There is plenty more. I don't know how far we should go.
Yeah, there were a lot of very good questions today. But as said, I think we will wrap them up and summarize for you and make sure that all the questions are answered also after the webinar. But is there still, Mikko, something that you would like to raise, or shall we start ending the webinar?
There's maybe one question that has come in two different questions in slightly different ways is the use of distributions. So you can have, especially for process times, so you can use distributions to define the process times, whether you're talking about human operators or other processes. It can be it can vary based on a distribution. It could be uniform, normal, log normal, exponential, whatever it is. And you can have a pseudo-random generator to generate your value for the actual process time for this and that case. So you can have variation there. That's no problem. And I think that's about it. I maybe
Thank-
one question related. Sorry, one question related to the video Reza was running there. So this is also, it looks very realistic, and yes, it does. And this is another video that was created with this Blender add-on that MIKKO mentioned earlier. So you can export your 3D scene into Blender and then just have these more lifelike videos available. But that's it. Thanks.
Thank you, Mikko. Can you see my slide again? So what happens now after the webinar?
Yes.
Yes, we can see.
Thank you. So as mentioned in the beginning of the webinar, so this session has been recorded, and all the presentations together with the recording and also the questions that we had will be sent to you after this webinar. So you will be receiving an email from us within a week with all the materials that you can then take a look afterwards. If you want to hear more about the following of the upcoming events, either webinars like this or then the possible trade shows and seminars in the future, feel free to follow us in our social media channels. And if you have any questions still, please feel free to contact us and send them to sales@visualcomponents.com. We have also added some very useful self-learning links for you, so you can go into more details and use the time that we now have when working from home, so to go into more details through these. But now I would like to thank you all for joining the webinar. Hope it gave you information and that we were able to answer at least some of the possible questions that you had before. So thank you from our side, and stay safe and stay healthy. Thank you.
Thank you, everyone. Bye.
Thank you. Bye.